Today we're going to be looking at finding the present value of an annuity. So an annuity is a series of equal cash flows that happen at regular time intervals. That is a simple, short definition, and for this video, that's all you need to think of an annuity as. So let's say this annuity is going to be 6 years. So we're going to get $1,000 at the end of 1 year, $1,000 at the end of 2 years, 3 years, 4 years, 5 years, and 6 years. So after the 6th year, this annuity stops. You don't get any more money. If this went on forever, went on for infinity, that would be known as a perpetuity. And I already showed a video on how to calculate the present value of a perpetuity. That will be linked in the description below. And I already showed a video on just calculating the present value of like a single cash flow. So if we wanted to find this present value of this $1,000 in 6 years from now, we would just do $1,000 divided by 1 plus the interest rate to the power 6. So we're just counting it back 6 years. So that's just kind of a quick overview. That will be linked in the description below. So go watch that video quickly if you need a quick refresher on calculating present value of a perpetuity or just present value of a single cash flow in general. Now we're going to go over an example. The question says you will receive $1,000 at the end of each year. So $1,000 at the end of each year for 6 years. If the annual interest rate is 8%, what is the present value of this annuity? So we're trying to find the present value of this annuity today. So we have $1,000 in year 1, year 2, year 3, year 4, year 5, and year 6. And then after the 6th year, we don't get any more money. So no more $1,000. Now, ignoring time value of money, a lot of people might be tempted just to say, well, it's going to be $6,000. We're going to get a total of $6,000. So the value of it is $6,000. But remember the time value of money. If you have $1,000 in cash and you put it under your mattress, and then 30 years later you go try and spend that $1,000, you're going to be able to buy a lot less with that $1,000 because of inflation. So remember that a dollar today is not worth a dollar tomorrow, and this time value of money concept is very important to understand. So thinking back to the present value of a single cash flow, one way we could do this is just discount all of these back to today. So year 1, discount that $1,000 back to today, then this $1,000 in year 2 back to today, $1,000 in year 3 back to today, and we can add all those up, and that will give us the present value today. So as you can see, we're just discounting. This is the $1,000 and what we're receiving at the end of 1 year. This part is the $1,000. We're discounting it back for 2 years to today, and we're adding up all those. And when you do that, you'll get a final answer of a present value of $4,622.88. But first, let's go over a couple of things. So the $1,000 that we're receiving at the end of 1 year, this is worth to us today the $925.93. So that is what this equals right here. Notice how that the $1,000 we receive at the end of 2 years is only worth $857.34, and each year it gets a bit smaller. That is just another example of the time value of money. $1,000 in 6 years isn't worth to us as much today as $1,000 in 1 year, because we'd rather have the $1,000 in 1 year, and then we can invest it and do other things with it. So $1,000 in 6 years is only worth $630.17 to us today, when $1,000 in 1 year is worth $925.93. Now this method works, but imagine this question instead asked us or told us you will receive $1,000 at the end of each year. So instead of this 6 years, imagine if it said you will receive that $1,000 for 30 years. So imagine you have to do this 30 times. That would be a lot more time consuming. That would take forever, and the risk of making a mistake would increase because you're adding so many different numbers. It would take you a long time. So there is a much more efficient way to do that, and that is using the present value of an annuity formula. So this is the present value of an annuity formula. So it's C times, and then one big bracket, 1 minus 1 over 1 plus r to the exponent t, and then that's just in the numerator here, and then all of that is over r. So C is the cash flow that we're receiving at the end of each year. So the $1,000, that's going to be our C. That's our cash flow. So that is what C is, and we're multiplying that $1,000 or C by 1 minus 1 over 1 plus r. So what's r? R is going to be the interest rate of 8%. So the R is here and R is here in this formula. So we're going to write that as 0.08, which is just that written, because remember that is a percentage. So 0.08, that's going to be our R. And then the exponent t, that is going to be our time or number of years that we're receiving this cash flow. So as you see in the question, it tells us we will receive $1,000 at the end of each year for 6 years. So T is going to be 6 in this example. So this is what you should get when you sub in the numbers. So remember, C is the $1,000 or our cash flow that we are receiving at the end of each year. So C is the $1,000. And we multiply that by this big bracket here. So in the numerator, we have 1 minus, then 1 over 1.08 to the exponent 6. So see the 1 plus r, that is the 1 plus the 0.08, which remember our r was 0.08 because our interest rate is 8%. So 1 plus that 0.08 gives us 1.08, and we know our t is 6, so we do it to the exponent 6. So that's our numerator. Then we divide that whole numerator, all we do is divide that by r, so 0.08. And when you solve this part of the equation, this big bracket right here, you come up with an answer for this part of 4.622879. And all we have to do now is multiply that by our C, or by 1,000. So the present value of this annuity is $4,622.88. And you'll notice that is the exact same answer that we got in the first part of this question, using the other longer way. Showcasing that both of them will get you the same answer. This formula is just a lot easier to work with, because again, if this wasn't 6 years and this was 30 years, this formula would get you the same answer as doing it the long way, but you can do it in the same amount of time as you did this question.